Okay, so this is going to be the review for our test tomorrow on May 9th. Let's kind of move this out of the way. All right, so we're going to go over a few of these problems here. Let's change the screen on this for us. Okay, so for number one, we're looking for the value of x. And the value of x is going to be the diameter that we have right here. Okay, so this is our value of x. So we know that this value right here, this segment right here, is equal to 11.8, and we know that this segment right here is equal to 8.2. So if we were to add these two together, we would get a value of 20 for the radius. Alright, well, this line right here is our diameter, and the diameter is equal to 2 times whatever the radius is. So x is equal to 40. Okay, number two, we are given a value of 4.6 for this segment right here. We're given a value of 8.9 for this segment right here. So that tells me that the entire segment is going to be 13.5, which is also the radius. So this radius right here, since all radiuses are equal in a circle, we have 13.5 as well for x. So I'm going to just do 2 of these right here, not all 4 of them. So again, this is my radius right here. So we can find circumference if we use the radius by 2 pi r, or we can find the circumference if we have the diameter by finding pi d. So in this case, we have c equals 2 pi times 5. So if we were to put this into a calculator, we have 2 times 3.14 times 5, and that's going to give us a value of 31.4. Okay. The next one, we're given the diameter, which is equal to 4. So to find that, we have pi 3.14 times the diameter, which is going to be equal to 4, and we get 12.56. Okay. All right, for the next ones. So again, I am looking for this value of x right here. Now, I know what this angle is right here. So if I know that angle, then consequently I know the value of that arc. If this angle is 57, then this arc is 114. Okay? Because the arc is equal to 2 times the angle. Alright, so now we know what the measure of that arc is. We also know the measure of this arc right here. It's equal to 5x plus 1. So if I was to take both of those arcs and add them together, well, they should equal a semicircle, which is equal to 180 degrees. So then we have 5x plus 1 plus this arc right here, 114, and that equals 180. So we have 5x plus 115 equals 180. So when I subtract 115 from both sides, we get 5x equals 65. Therefore, x equals 13. The next one, again, this belongs to this angle right here. So we know that this angle equals 4x plus 9. Its intercepted arc is equal to 106. So the arc is equal to 2 times what the angle is equal to, 4x plus 9. Okay, so simplifying that, over here we get 106 equals 8x plus 18. So we're going to subtract the 18 from both sides, and we get, let's see, what is it? (8x) equals 88. Therefore, x equals 11. Okay. Number 9. Again, we have the angle here. We have its intercepted arc right there. So that tells me that the arc is equal to 2 times the value of the angle. So we have 15x plus 11 equals 16x plus 2. So if I subtract 15 from both sides, we get x. If I subtract 2 from both sides, we get 9. Okay. For number 10, again, we know this angle right here. This is of course 90. We know the arc that it intercepts. But this arc is equal to 180. So we can say 26x minus 2 equals 180. We know that from the arc. We also know that the arc is twice the angle. If the angle is 90, then that equals 180 for twice. So we have 26x equals 182. So then we have 182 divided by 26, and that gives me 7. Alright. Now of course, if on this, number 11, if AB is going to be tangent to this circle, then my radius or diameter has to be perpendicular, which means that it will create a right triangle. If it is perpendicular, then I can prove that using the Pythagorean theorem. So my hypotenuse, C, is always across from the right angle. So we have 21 squared equals 12 squared plus 16 squared. So we get 21 squared, which gives us 441, equals 144 plus 16 squared, which gives me 256. So if 256 plus 144 equals 441, then we have a right triangle. Well, we find out that 441 does not equal 400, therefore it is not a tangent line. A line, singular. Okay? Alright, so with this one right here, same rule applies. If this line right here, AB, is going to be a tangent line, then this line right here has to be perpendicular. So therefore, we have 19.5 squared, because that's my hypotenuse, should equal 15.6 squared plus 11.7 squared. All right, so just calculating it out again, we have 19.5 squared, which gives me 380.25. And if that equals 15.6 squared, 243.36 plus 11.7 squared, 136.89, then we have a deal. So 136.89 plus, actually we want to go back. Nope, can't do that. All right, so we have 243.36 plus 136.89, and that in fact does equal 380.25. So since they equal each other, then we know that AB is tangent. Okay. All right, now for these last ones right here, these are a little bit different than what you had on your review, and that's primarily because when I generated new problems, I didn't save the ones that I gave you guys. So we're going to kind of explain this again using these examples right here. Okay. So again, if I'm looking, I have to remember that if I have a exterior point, okay, and that point is tangent, or that line is tangent to a circle, from the exterior point to the point of tangency, they're going to be congruent to each other. Okay? So then if this side right here is 14, then this side right here is also equal to 14. We're going to minimize this pen a little bit, give ourselves some more room. So let's just kind of erase this so we have some room here. And we know that we just explained that this side right here is also equal to 14. Okay? Which means that this from here to here is the difference between 14 and 9.5, which we get 5.5. Actually, these are the same problems. Okay? So then we know that this side will be 5.5, which tells me that now this segment right here from this exterior point to that point of tangency, to that point of tangency to that exterior point, these are going to also be equal. So that means that I'm going to have a difference of 10.1. No, I'm sorry, 9.9. I don't know why I did that. 9.9. And then we have this side right here, which is also 9.9. And what we're looking for is the perimeter. Okay, so I now know that this side right here is going to be 19.8. This side right here we already knew was 15.4, and this side right here is 19.5. So again, last if from the exterior point to the point of tangency is 9.9 here, then it will also be 9.9 here. And so if I add 14 and 9.9, we get 23.9. So if I add 19.8 with 23.9, with 19.5, and with 15.4, I'll find the perimeter. Same thing here for 14. 14, if this exterior point to that point of tangency is 7.1, then this is 7.1. If from the point of tangency to the exterior point here is 8.8, then this is 8.8. Hang on. All right. And then that tells me that the balance for the segment is going to be 9 on this side from that exterior point to that point of tangency, and therefore it would be 9 here as well. So this whole side right here is 16.1. We have 15.9, and we have 17.8. So if I was to add all three of these together, I get the perimeter.